Welcome to hole number 6 of the Adventure Golf unit. Hole number 6 will be focused on the interior angles and interior angle sum formula and exterior angles and the exterior angle sum formula. Please take a minute to copy down the vocabulary. Pause if you need to. I'm going to continue moving on. How many degrees are in the interior of a triangle? This is prior knowledge that I would expect you to be bringing to 7th grade. All triangles have a total of 180 degrees on the inside. So if I look at a right scaling triangle and I say that this is a right angle, 90 degrees, and I give you the angle measure of this as 70 degrees, I know that the three interior angles must add up to 180, meaning 90 plus 70 is 160. My last angle must be 20 degrees. We will use this idea that triangles have a total of 180 degrees to begin to build and look at other polygons. If I look at the polygons listed here, I've got a variety of different polygons. I've got a rectangle, a pentagon, a hexagon, and an octagon. So a rectangle is a type of quadrilateral. It's got four sides. And if I strike a diagonal from one vertex, so we'll put a segment from A to C, I've taken my rectangle and I've split it into two triangles. So this quadrilateral has two triangles. The pentagon, if I strike diagonals from one vertex, in this case I'm going to come down here, and then I can do a diagonal here. Diagonals go to all of the non-adjacent vertices. So it wouldn't go here because that vertex is adjacent. Wouldn't go here because it's adjacent. But the pentagon divides into three triangles. The hexagon, again, diagonals from one vertex to the other non-adjacent vertices, splits into 1, 2, 3, 4. The octagon, to all non-adjacent vertices, splits into 1, 2, 3, 4, 5, 6. And what you should notice, octa means 8, hexa 6, penta 5, quadrilateral 4. In each case, the number of triangles is 2 less than the number of sides or the number of vertices. The number of sides and vertices would be the same for each shape. A heptagon, hepta means 7. Based on this pattern, I would predict that a heptagon would split into 5 triangles. If I want to know how many degrees are in the inside of each one of these shapes, I can simply look at the number of triangles and the number of degrees in each triangle. So for example, here I've got 180 and 180, there's 360. Here I've got 180, 180, 180 is 540. So in summary, I'm going to take the number of sides, S, I'm going to subtract away 2, and that right there would give me the number of triangles, as you can see here, 4 minus 2, 5 minus 2, 6 minus 2, 7 minus 2, 8 minus 2. So the number of sides minus 2 will tell me how many triangles are in each shape, and then I can simply multiply that times 180, and that will give me the total number of degrees inside of a triangle. Here I would have 2 times 180 would be 360. 3 times 180 would be 540. 4 times 180 would be 720. 6 times 180 would be 1080. Looking at these shapes and applying what we just talked about, this first shape I've got 1, 2, 3, 4, 5 sides. So I'm going to take 5 minus 2 and realize that this pentagon would split into 3 triangles times 180. I've got 540 degrees total in this pentagon. From that, I'm going to subtract away what I've already got, 540 minus 121 minus 103 minus 85 minus 68, and I find that my last angle here, I'm just doing that, appears to be 163 degrees. Will be my missing angle. Here I've got 1, 2, 3, 4 sides. So I'm talking about an irregular quadrilateral. Take the number of sides minus 2 will give me the number of triangles. 2 triangles times 180 means I've got 360 degrees total in this shape. I'm going to subtract away the angles I already have, 131, 106, 67, and I find that my remaining angle is 56 degrees. Now in this case down here I have a special shape. This is a hexagon, and I can tell it's a regular hexagon because each side length has 1 tick mark, meaning that each side is congruent. Each angle has 2 tick marks, meaning that each angle is congruent. I can take 6 minus 2 and realize I have 4 triangles times 180. I've got a total of 720 degrees here. And if I want to find the angle measures, because I have 6 angles and they're all the same, I can simply divide by 6. And I find that each angle measure is equal to 120 degrees. So each of these angles would be congruent at 120 degrees. And this division only works with regular polygons. The last shape I have down here, 1, 2, 3, 4, 5, 6, 7 sides. 7 minus 2 means I have 5 triangles. 5 times 180 equals 900 degrees total. And if I subtract away the angles that I already know, 161, 102, 165, 123, and 128, 900 minus 161 minus 102 minus 165 minus 123 minus 128. I'm left with 221 degrees. And that 221 degrees must make up this angle and that angle. So 221 equals angle x plus angle x plus 11. Now this is going to require us a small amount of algebra here. We're going to look at this and say, do we have any like terms? I've got 1x and 1x, so 221 is equal to 2x plus 11. Inverse operations tell me to get rid of the 11 first. It's our floater. 2x equals 210. Divide by 2. Divide by 2. X equals 105. And in this case, this angle here is 105. This is 105 plus 11, which would be 116 degrees. Now, we were looking at the interior angles. Now we're going to shift gears and look at the exterior angles. So for example, if I have a triangle we just finished looking at this angle plus that angle plus that angle. 3 different angles. And we realize that these all add up to 180. What we're looking for now is what this plus this plus this would equal. If we look at start with quadrilaterals, we know a quadrilateral has 4 vertices. 1, 2, 3, 4. And each one of these vertices would have 360 degrees going around that vertex. So I'm going to take the 4 times 360, and I realize that this has 1440 degrees total. And I know that there are 360 degrees on the inside because there are 2 triangles. So if there are 1440 degrees total in this shape and 360 are on the inside, that would mean that the outside would have 1080 degrees. 1440 minus 360 equals 1080. The pentagon is the same type of problem. 5 vertices, so I'm going to take 5 times 360, and I'm going to find that this has 1800 degrees total. And then I need to subtract away what's on the inside, excuse me, which would be 3 times 180. 5 minus 2 is 3. 3 times 180 is 540. And I end up with 1260 degrees on the outside. The hexagon is the same way. And I'm going to go ahead and write all of this in one long formula starting here, just so you can see how I can put this all together at once instead of doing it in steps. I can take the 6 vertices, multiply it by 360, and then I can subtract away 4 times 180. And I came up with 4 by just mentally saying the number of sides minus 2. And when I do this, 6 times 360 minus 4 times 180, (6 times 360 minus 720 equals 1440. And you could go ahead and fill in the rest of this. Looking at it, let's say we have an 11-sided shape. I'm going to take 11 times 360, and then I'm going to subtract away what would be on the inside, which would be 11 minus 2 times 180. 11 times 360 equals 3960. And then I'm going to subtract away the 9 times 180, which is 1620. And the total number of degrees on the outside of this undecagon is 2340 degrees. Again, the total number of degrees minus the interior number of degrees gives me the outside number of degrees. You're now ready to get online and print the 6th hole scorecard.